Good morning.
Morning.
Hello?
How's everyone doing?
Morning. Good. Morning, everybody.
Morning all, or afternoon even.
Give it just a couple minutes here. All right, maybe we can just get started. I think looking at the agenda today, Giles, you're going to give us a demo of your implementation?
Yeah. Well, we were going to sort of talk through it. I had a few slides, and I was going to talk through what our approach is, and then I think Nikos was going to show a demo, if that's okay.
Sure. Hold on. I think I'm gonna have to enable sharing here, or maybe.
Sure.
Actually, Paul just joined. Paul, are you currently logged in as host to enable sharing?
I am just about to. My bad.
Perfect. No worries. I was about to do it too, but I don't have the credentials.
The perennial sharing issue. Okay, 1 second. All right, screen sharing is enabled.
Right.
Sorry about that.
So, so I can remember how to use Zoom. Right, share screen, that's it. Oh, this is great. It wants preferences to share my screen. I thought it already had it. I'm gonna have to quit Zoom and come back in. Guys, I'm really sorry. Give me 1 second.
No problem at all.
We have all been there.
Hey, Valerie.
Hello.
Right, hopefully this time it'll work. Sorry, guys. I could have sworn I enabled this the other day. This is the downside of working for Cisco and tending to use WebEx for most things. So yeah, so basically, if I give you kind of a very brief overview of the history of this, we were already looking at multi-cluster networking before we read the KEP. And so what we did was we took the approach we were already adopting and kind of mapped it onto the KEP APIs, 1645. So what I called it is, multi-cluster services, leveraging existing tool set. And I'll come on to how we do that. So yeah, basically, what is the problem statement? Here's our approach. And I'm just going to run through very quickly how we do regular Kubernetes services, how we do headless services, and how we handle non-Kubernetes stuff. So basically, this is just the KEP 1645 problem statement, really, isn't it? Being able to produce and consume services, have services across multiple clusters, being able to have some kind of policy for those. Ultimately, of course, we want to also integrate with bare metal VMs, serverless, etc. So that's just a picture of, what are we trying to achieve? But then, okay, if I come to how does it work? Well, the key concept we came up with was this idea of a proxy Kubernetes service. So that's to say, if your source cluster wants to access a service in a remote cluster, what you do is you create a service instance in your source cluster that maps onto a set of edge pods. In our initial implementation, those edge pods are running FIDO VPP, but of course that's not required. That's just how we got it up and running. They can be anything, but the key thing is those edge pods really act as a deployment. And then effectively they use port numbers to identify services. So we create a proxy service. It looks like a regular service in that cluster, but what it will do is it will map onto the set of edge pods on a port number that tells the edge pods which remote service it is. So then for a headless service, it's a little bit different. We create a proxy service for each endpoint. So each endpoint we add, we need a new proxy service in the source. And then equally, if we want to access stuff that's outside Kubernetes, again, we just create a proxy service and that works. And equally, of course, we can reach into clusters from outside using the same kind of approach. So we looked at it and really, again, correct me if I'm wrong, from my reading of KEP 1645, it seemed to be saying that in as much as you have an endpoint slice or one or more endpoint slices for each remote cluster, then you are relying on the fact that the CNI space doesn't overlap between those clusters because you effectively have sort of a flat network to reach those endpoints. And effectively what we wanted was an approach where we could just assume that out of the box, the clusters might have overlapping addresses. They might all have exactly the same CNI addresses and the same cluster IPs, but we still wanted it to work. But we also wanted it to work regardless of which CNI you were using and without any changes to kubeproxy. I mean, there are improvements probably you could make if you allow changes to kubeproxy, but we wanted to avoid that. What we really wanted to avoid, and really this comes down to scalability, was any requirement to track the remote cluster endpoints. So we wanted to take an approach where each cluster was kind of responsible for looking after its own resources, and where a remote cluster that's accessing a service in a cluster just needs to know, here's the cluster IP for the service. In fact, we use a VIP between clusters, but that's all it needs to know. It doesn't have to actually track what the endpoints are for that cluster. In the case of a headless service, it just needs to know how many replicas there are. It doesn't need to know what the current IP address of each replica is. So it's much more of an intent-based approach saying, there are 5 replicas, we'll create 5 proxy services, but we don't care where those, what IP addresses those replicas end up on. We don't need to know. That's a concern of the remote cluster. It has a nice little security property as well, I guess, which is that you can only reach services that are being exported. So all of the stuff we'll show with the proxy services, it's basically created based on having service exports and service imports. So there is no IP reachability between clusters. You can only reach services, which is why I've kind of called it service routing.
That's pretty awesome. Quick question, if you don't mind.
Yeah. Sure.
So for headless, does it actually create like a headless service that's if I do I get a service name that returns all of the IPs?
Right. Yes, your multi-cluster service would return a set of IPs where each of those IPs was actually a proxy service in the local cluster.
Okay. Okay. Cool.
One of the things there's a couple of things you have to get your head around with what we're doing that are a bit wacky. One is the fact that we're effectively using port numbers to identify services. So you kind of flip-flop from a client relying on the IP and then the edge pod, well, the proxy service and then the edge pod, using a port to identify the service. The other thing is that the DNS view of the world is going to be different in different clusters. So we will potentially, for the same domain name, we might have to return different IP addresses in different clusters.
Right. That seems fine to me. That seems very compatible with what we're going for with the CAP, because there's no real guarantee that, like, I think we specifically wanted to avoid any guarantees that the IPs are actually the same or anything like that.
Right, right.
To enable creative solutions.
Yes, yes. Okay. So that was, that was very much our goal, was to, as I say, to do it all based on services, and that those were just sort of the sort of things that fall out of it, that they're perfectly logical. It's just that perhaps people take a little while sometimes to wrap their heads around it. Right. Particularly the thing of using ports to identify services. So if I do a quick walkthrough of what would happen with a regular service, your client pod, so it's going to look up in DNS, it's going to get an A record. Based on that A record, that's going to direct it at a proxy service. And of course, the client is going to fill in a port when it opens a socket. Of course, having hit that proxy service, you're going to say, well, 10.96.1.1 port 80 is going to map to my deployment, my set of edge pods, but my target port is going to be 12345 rather than 80. And of course, that means for a multi-port service, you would have to effectively translate each port separately. But of course, these proxy services effectively you create one per port, rather than those being multi-port proxy services. So now it's that port 12345 when it arrives at an edge pod. And again, you can see it's just arriving over the CNI. These IP addresses are all just regular CNI assigned addresses. And so there's probably some kind of a VXLAN or IP and IP tunnel or whatever between the two pods, but we're ignoring that for now. That port number is what's now going to identify the VIP. The VIP really is just something that's shared between our edge pods to identify services. It turns out you don't need VIPs. I'm talking to the people who do our NAT and VPP, and I've got a way of avoiding VIPs entirely. If you know what your next hop is, if you can do a NAT that points at a next hop, then you don't actually need a VIP. But again, maybe they help people in terms of understanding that the VIP is identified with a service, or in the case of headless, with an endpoint. And so based on that VIP, we're going to route out across the IPsec tunnel. So if you think in terms of now perhaps a service that's actually in cluster 2 and cluster 3, and perhaps there are 5 replicas in cluster 2 and 10 replicas in cluster 3, what you're going to do is send 1/3 of the traffic to cluster 2 and 2/3 to cluster 3. So you'll do an unequal cost multipath routing decision. But then it'll go through the IPsec tunnel and land in cluster 2 in this case, as 1 1/3 of all flows will. And now cluster 2 is going to say, okay, I've got that VIP, and I know that VIP corresponds to this real service that's got a cluster IP in my cluster. What it'll also have to do is source NAT. And the reason for the source NAT, again, is because the CNI, the remote edge pods need to know how to route back to this, sorry, the remote application pods need to know how to route back to this edge pod.
Right. Okay.
In fact, I now can't see the rest of my builds, but I'm assuming the rest of the build works. We go through a regular service again, it maps onto a set of replicas, and then the packet will land on one of those replicas. In the reverse direction, everything's just going to be based on the NAT state that we've already established.
Okay, awesome. Yeah, and so that's cool. You answered my question about how you do weighting, because one of the reasons why we started with the flat approach, but by no means wanted to require the flat approach. But we started there because weighting is an important part if you have an unequal number of backends in each cluster.
Yes, and so we have, again, in the VPP implementation, we have an equal cost multipath support. Now, obviously, at some point, our goal, to put it up front, our goal with this would be to open source it, get it into the community, but equally, we understand and expect that not everyone's going to want to use FIDO VPP. So I would hope that somebody might implement the edge using eBPF or using OVS or whatever it might be. And so that's then a constraint, do they also support unequal cost multipath? But again, it's very intent based. So if you've got, as I say, like say 5 endpoints in one cluster and 10 in another cluster, it'll just send 1/3 to one and 2/3 to the other. It's not actually tracking whether the requested 10 replicas are all up, because that's the concern of the remote cluster to do that.
Right. Okay.
Bear in mind, the background of this team, certainly Jan and I are both people from very much a sort of SP background, and we think in terms of things like BGP. So we tend to think, right, make each cluster responsible for its own problems, and make the clusters not have to know each other's problems. as much as possible. And then, from a headless service approach, it looks a bit more complex, but really it's just the same, that your client's going to do a lookup. It's going to get these multiple A records. And as you can see here, those A records are each actually cluster IPs for different proxy services in my local cluster. So it's going to pick one of them. And having picked it, it's really just going to follow through the same thing, that proxy service, you can see now that the proxy service for the first endpoint is on port 10,001. For the second endpoint, it's on 10,002. And having picked the 10,001, that's going to flow through to the edge pod, which is going to use a VIP, in this case 172.16.1.1 rather than 1.2 for the second endpoint. And now when that hits the edge pod in the remote cluster, it's not going to use kubeproxy. It's now going to know directly, okay, I need to go to that endpoint. And so that's headless. But we can also take the same approach and extend it to reaching out to resources and reaching in from other resources. So, effectively, we just create a proxy service, which again just maps onto our edge pods, and that can then point us out to some kind of external service. And the same reaching in. Again, we would just use the same kind of machinery in our edge pod. Of course, in this case, this is a real service, not a proxy service we're going to. But what we wanted was to kind of have this one approach that we would use for, regular services, multi-cluster headless services, reaching in, reaching out. I think in the case of people then sort of start thinking about service mesh, and that's one of the contrasts here, I suppose, because if you have a sort of flat IP space, probably what you want to do with multi-cluster Istio is run a single control plane. However, in our case, Istio control plane. However, in our case, because we don't have that flat network, we'd probably take the approach where we go through gateway pods in the remote clusters. And that's something we've not set up yet, but that should work fine. Because I guess, and that's one of the interesting things with all of this is like, what's our expectation on percentages of deployments that are actually going to have a service mesh? And really all we're doing is enabling that multi-cluster service mesh versus cases where it's not service meshed. And again, the sort of reach in and reach out versus actual multi-cluster, I'm not really sure, in reality, what the kind of ratios there. In terms of, so that's sort of the data plane. In terms of how we built the control plane, I mean, Nikos can show the demo, but fundamentally, we've taken that model of having like a centralized control plane, but then with agents in each cluster, as well as edge pods. So Nikos, do you want to grab the, whatever Zoom's equivalent of the ball is? Because I think that was my last slide.
Yeah, sure. Yeah, Nikos, just show the architecture maybe up front with the one slide and then go into the demo.
Yeah, 1 second. I need to do anything there.
Your audio is a bit blocky, Nikos.
Yeah, your audio is not very good quality, Nikos.
Which is exactly what we had earlier today on a WebEx, so we can only blame your headphones. Are you back?
Yeah.
Awesome.
All right. Yeah, I had to do the same thing that you did with the access. All right, let me share. You guys can see my screen, right?
Yep.
All right. So essentially, this is the architecture that we have. It's fairly simple. We have basically something called speakers, and this allows us to talk to essentially a northbound controller. And this is basically the MCS agent that runs in every basically cluster. And southbound speaker essentially is what we have, like the component we have to talk to our data plane. And this basically have different implementations, like Giles mentioned. Essentially, we have BTP now, but we're open to have different implementations here. Then we essentially have a
question really quick. Could you just explain exactly what a speaker is? I'm unfamiliar with the term used in that manner, so I'm just a little curious if you can add some color.
Yeah, so speakers essentially it's basically the component, or we call it speaker, right? But essentially it allows us, it provides with the communication to the northbound, right? So essentially it creates a gRPC connection up to the controller, and then that's the way to communicate through gRPC to the controller northbound, and then southbound we have kind of the same.
Is it
the audio cut out for me?
Yeah, yeah. Nikos, I think it was your audio died there for a moment.
Yeah. So basically, the speakers, they talk to the controller, they update their cluster information, tunnel information, what have you, like what services are available. And the controller is basically a reflector. So it gets, all this information from all the clusters and then reflects it to all the other clusters. So basically the gRPC is a two-way streaming gRPC call. The agent pushes information into the controller, and the controller pushes information into the agent from other clusters.
Yeah, I'm really having problems with this Zoom call. Give me 1 second, maybe.
Just a quick question then. So in the diagram you showed before, is a speaker one of the edge pod blocks?
No, the edge pods are the purple blocks at the bottom. So the agent, and we could co-locate it with an edge pod, but most likely it'll run separately and control multiple edge pods.
If you can share, can you just share maybe one of the high-level architecture documents? I mean, that's going to be much clearer than, because this is the agent blown up into components that it's like more of an implementation or design detail.
You mean from the Google Doc? Or is Nikos showing it?
Stop sharing.
Yeah. Okay, quickly I'll share. Sorry guys, I'll share this. You're thinking this one, Jan, right? The yeah. So this is our sort of a high-level view where we have the MCS controller, and then each cluster has an MCS agent, which is basically the exploded thing that Nikos was showing, and that will then control multiple edge pods. But so there'll be two speakers effectively, one talking northbound to the controller, and one talking southbound to the individual edge pods, and that will be sort of replicated in each cluster. I think that was the one Jan was after. Yeah, this is all starts to blow up more, but yeah, that was the kind of the highest level view. Yeah, I think that was it really, Jan. Nikos, do you want to try again and see how your audio is?
Yeah. Can you hear me now better?
Yes.
Oh, yeah,
yes.
much better.
All right. Yeah, if you can stop sharing because I cannot share.
Oh, sorry, I thought I had.
All right, so yeah, basically we have an implementation for the CAP 1645. Essentially in this demo, we will try to showcase a supercluster that has 3 clusters, cluster A, B, and C, and then 2 of them are actually running Nginx, like an Nginx service. We have them actually in the default namespace, not that it makes any difference. But yeah, both cluster A and cluster C essentially run an Nginx service that they want to expose basically to cluster B. So, the normal flow would be someone would go and apply a service export CRD into Kubernetes, and then this will be pushed into our centralized controller, and that will turn and create the service import and advertise that to all the other 3 clusters, so that basically cluster B can access the Nginx endpoints through a proxy service that we create in cluster B. And we can, yeah, I guess I can show the implementation now. So we use a kind basically to create a setup of the 3 clusters. And let's say cluster 2 and cluster 3, they run the Nginx service. I can show you the services as well. Service, so kind 1 doesn't have any services, so it doesn't want to expose any service right now. So basically we want to use kind one to get the imported services. And then cluster 2 and cluster 3, they run the Nginx service. And as you can see, we actually have the same cluster IP for Nginx. So, we can have overlapping IP addresses. And okay. So basically right now from the pods, we have the controller in cluster 1. So basically the centralized controller is running on cluster 1, but you can think that this controller can run individually on a separate cluster without any, other edge pods running there. And we can essentially start the agents. So this will create the MCS agent, which is basically responsible to hear for changes for service exports and service imports. And then we can see here, this is basically the agent, and I can get into the edge pod just to see things getting programmed on demand. So let me get into the edge pod. So we have the IP tunnel interface, and right now we don't have any security association. So basically I don't have any other clusters being part of the supercluster. It's just basically cluster 1 that is part of the supercluster. So let's add some clusters in the setup. I'll go and add cluster 2. And then you see that basically now I have an IPsec tunnel between cluster 1 and cluster 2. And then basically I have a route to get out to that cluster. I will add a third cluster as well. New security association, new tunnel to the new cluster. And then let's go and see our services. So basically, like I said, cluster 3 has Nginx running, same for cluster 2. So let's try to expose, let's say, from cluster 2. What we can show is not the application service, sorry, it's the service export. Yeah, so the definition of a service export, basically, according to the spec, we have to define a service export that has the same name and the same namespace of the application that we want to export. And essentially, this has to be consistent across all the clusters. So if I have an Nginx service, it has to be similar on all the clusters, and it has to run on the same namespace. So let's try to export that now. And it's as simple as kubectl apply service export. And now you can see that basically we have a new route to the new service proxy. So let's take a look at how this looks from a services perspective in cluster 1. So in cluster 1, we basically created a new service proxy that basically an application pod that needs to access that Nginx service on cluster 2 will have to go through. So let's create the curl pod. Which one is it? Yeah, the curl. Okay. So kubectl apply CS curl context currency one. So basically, I'm creating a client that basically wants to access that Nginx service, and then let's go in that curl, and then we can curl basically with the service name. And we see that we can hit basically the pods that are the backends for that service. Now let's try to export that same service from cluster 3. As you can see, now I can hit cluster 3 as well.
Awesome.
Yeah. And then, let's have a case where basically a cluster goes down. So I'm basically deleting the agent. I will only be accessing cluster 3. And then, Let's simulate a drop on cluster 3 as well. Yep.
Awesome. This is super cool.
Mm-hmm. Yeah, that's how far we've got so far. That's in 14 days almost of code.
Wow. Yeah, this is wicked. A couple questions. Did you, I guess, do you have any feedback or did you hit any snags when implementing the CAP?
Well, we hit a lot of snags, but that was basically difficulties in implementing, the whole data plane to control plane. But the spec, I think it was pretty straightforward, right? I mean, the controllers were very easy to write, both the service export and service import controllers. So that wasn't a big problem. And I think the spec is very clear. The only difference we have with the spec is basically we don't advertise endpoints, right? We just advertise the service export. So,
and Nikos Nian, weren't you saying that you felt that the service import model maybe would be cleaner if you had a service import from each cluster that was exporting?
Exactly.
So
yes.
rather than consolidating into one service import, that was probably the only thing that we felt.
Yeah, I mean,
would be different.
Yeah.
Okay. Yeah, we should discuss that. And I don't know if today's the right spot or on the doc, or that's an interesting conversation to have. Part of I think where we went with the original service import was the idea that we really do want all of the services with the same name to be blended, and that if you wanted individual addressing, they really feel like maybe they should be different services. But that's always the type of thing that we should discuss. And if you have, I'd love to hear a different perspective. And then also very good feedback on the endpoints. I think you've just shown that it's possible to implement the behavior, which is really all we really wanted to document with that API, without necessarily propagating the endpoints.
Mm-hmm.
Yeah, I would say, but we will be still interested in the count of the endpoints in individual clusters, so that we can load balance, so that we can do the unequal cost load balancing with proper weights, right?
Right. Yeah, and so that was part of why we originally did actually include that. I think there was some back and forth about should we include that there is endpoints or not, and we started going towards yes, because people might want to build on top of this with some understanding of at least counts. But I tried to spell out, maybe I did a bad job, but the endpoints don't necessarily have to be the original exporting endpoints. So if it was like the endpoints to your to those services that you create, that might be acceptable as well.
Right. Yeah, and I
So
think
Sorry, please go ahead.
Yeah, I was going to say, I mean, to Rasso's point, I guess, yeah, we probably, if we had separate imports from each cluster, then yeah, maybe the import could just have to counter the number of endpoints. And that might be all we'd need if we were happy to just track the required number of replicas rather than real time track how many were up. But yeah, I guess the thing is in the case of a regular service, so non-headless, we only need to know the count. We don't actually distinguish them from our point of view. So there is nothing really in our cluster. In the headless case, then yes, we're going to have a separate proxy service for each one. So it's kind of funny because the KEP has a VIP for the regular case and not for the headless case. For us, it's almost the other way around. But as I say, I don't think so that was one thing that we probably wouldn't bother with the VIP. As I said, I think when I was presenting the slides, I actually have figured out a way that we could not use VIPs at all. Because as long as the source cluster knows the cluster IP that's been assigned in the remote cluster, or at least the control plane does, and as long as you have a way in your NAT to set the next hop, then you don't even need VIPs. But again, some of this is around not only what's the most elegant way to make it work, but also what is something that people are going to understand.
Well, don't you still have a VIP though with your created service on the importing cluster?
Well, on the importing cluster, we just use one of those proxy cluster instances. It's a proxy cluster IP, so that's just a regular,
right? And
that's locally assigned rather than being something global.
Right. So that's totally a valid implementation.
Yeah.
So that actually,
yeah.
If you look at the SIGs, we've got the alpha repo up. We've actually followed a similar approach for the first pass, which is to actually use a service in the cluster for key proxy programming, and then the service import VIP just becomes that proxy cluster IP.
Okay, excellent, excellent.
So this is awesome. Yeah, what you showed us today is excellent.
So I was just going to ask.
Sorry.
I was just going to ask if there's anything that we could clarify around like endpoints in the proposal. It sounded like there was like a question of, did we do something that was okay?
I think maybe the thing would be to make it sort of optional and have it, maybe have some wording around perhaps the two different ways of or at least two different ways of implementing. One where you create a sort of flatter network space and track endpoints, and one where you use proxy services instead. I don't know when, but we could maybe suggest some wording there or whatever.
Yeah, I mean, that would be great if you wanted to make a PR or.
Yeah, sure. And as I said, I mean, we started this work before we became aware of KEP 1645. So we actually ended up modifying our implementation to align with it. But having done that, you know, obviously we would love to see our stuff sort of folded into the KEP as a sort of, this is one good approach for doing it. And really, you know, ultimately yes, we came up with this inside Cisco, but we don't want this to be a Cisco thing. We want to make sure that, other people get on board and it gets traction.
Yeah, this is awesome. Thank you for showing this. I do have to ask, could you add the slides and docs and stuff you talked today, or any of it, to the notes? Because I think
we should be able
really
to.
Neat to read through. This is excellent.
Awesome.
Yeah,
we can do.
Thanks a lot for the demo. Appreciate it.
So
Yeah,
a question here, would you guys, or would somebody be interested in actually setting this up as an open source project and maybe taking it to CNCF or, you know, any kind of a body? And would you guys be interested in working on that?
Yeah, I think that we should definitely talk about what that could look like. And, you know, this is very interesting.
I'll just ask you to like repeat that ask on the email list, just so it has like the widest possible reach. I'm gonna do my best to get the recording up today, but I think you'll get wider reach on the list.
Brilliant.
Okay, perfect.
Yeah, and it would be great to include the slides and everything on that as well. So that people
awesome. We'll do.
I mean, I guess I have one question. It occurs to me that means that there's a very different architecture between a flat network and a I guess isolated network with like IPsec tunneling and stuff like that. Are we as a SIG going to have an opinion on both, or are we just sort of abstracting ourselves from that differentiation?
I think that's a very good question, and something we should certainly talk about. My initial assumption that needs to be discussed more and is that we don't really want to take a stance necessarily. I think if so long as it doesn't impact how things are used, it seems like multiple implementations are okay. There are certainly flat network deployments out there that I don't think we want to dictate that you can't have, but at the same time, obviously, there are not flat networks as well, and we need to be able to handle those. And I don't know that we want to dictate right or wrong. I don't know if anyone else has any opinions there.
Yeah, the non-flat networks are actually kind of more generic case, and especially if the clusters are in different admin domains, right? I mean, you cannot say it's going to be one flat network and what have you, because it can be, you know, service exporters in company A and service importers in company B, and, you know, they want to consume some services that somebody provides. And, you know, these non-flat networks allow you to go into places like, okay, so let's do a service broker actually based on something like this, right? So it's quite the generic approach. And if you happen to have a flat network underneath, I mean, it's still going to work.
Right, but if you dictate a non-flat network, then, you know, there's certain decisions that can't be made.
Yeah,
so.
I'm not saying we should, but I'm just kind of giving the background a little bit, you know, on why we went the way that we went, and what it allows and enable.
Yeah, it absolutely makes sense.
There's room for a diversity of implementations, and, you know, that I think was one of our one of our values, explicit or not, in working from like an API standpoint at the level that we did. So there is nothing wrong with having multiple implementations, and that doesn't necessarily mean that you might only have one implementation of each type, right? Like there's no need that everything be factored down to one thing of broad type only.
Absolutely.
Right, yeah.
And as Giles pointed out, I mean, we're networking people. We're used to implementing RFCs and specs and what have you, protocols. So API is a perfect way to go and then, create the implementation from that.
Yeah, I think what we really want to do, and this is where feedback would be great, is make sure that we really get enough of the behavior on the user-facing side, how you actually interact with these services and what you can expect when they're exported and imported, so that regardless of what those implementations end up being, we have many out there eventually, hopefully, and they you at least can use them in a consistent way and build some consistent tooling on top of them.
Right.
Yep.
Okay, so Jeremy, I think you've got another tick on the agenda after this.
Yeah, I can share. This will be super quick. Andrew, who had to sign off, unfortunately, put up a PR to expand the alpha repo to support. Actually, maybe I won't share. I'll just leave it linked. But basically, to optionally add use the service status load balancer IP to let you specify external addresses on the service import and have that program through that alpha implementation that uses the dummy services. I think this is along the lines of what we talked about. I thought it was awesome that we got a PR so quickly on the SIGs repo. So to me, it seems like we should definitely merge this. So the existing behavior was that you create a service import and it gets its IP from a derived service that's used to program kubeproxy. With Andrew's change, you can also supply an IP on the service import when you create it, and if it doesn't, basically, if necessary, it will set it as the load balancer IP on the service, which makes everything work. Has the downside temporarily of also using a cluster IP, but this is that alpha approach we wanted to take to avoid having to program kubeproxy yet anyway. So I was planning on merging that unless anybody had any major concerns. Cool. Well, it's linked in the notes, so take a look, and if nobody has any objections, I'll probably merge it this evening.
Okay, so I had one more thing on there, just a couple of reminders. First is that we have the cluster registration and cluster set use case documents that are world writable, that are open. And we're really interested to know if folks have interesting use cases they want to share. I would say there's no rush, but I just want to really literally remind people that they are open. The other one is that Chojin posted a kind of proto-KEP document for the Work API that I just wanted everybody to be aware of. He posted to the mailing list earlier today, but I've linked all those documents that I mentioned in the agenda. That's it.
Awesome.
Okie doke. Sounds like we're talked through for today. Thanks, everybody. Really great demo. Thank you very much, folks from Cisco.
Hey,
Yeah,
thanks,
thank
guys,
you.
for giving us the
Excellent.
opportunity.
Thanks, everyone.
All right. Have a great day, everybody.
You too.